Very much for clicking on this video. I welcome you to this our series. This is episode 2 on acid, bases and salts. In this our acid, base, salt series, we are trying to cover up an acids, bases and salts, and in this video we are looking into a base. That is, what do we actually mean by a base? What can we use to identify a base? Mind you, when we discuss acid, we were able to distinguish between an acid and acidic salt, where we say that for it to be an acid, it must have only one positive ion, which is hydrogen ion. We can even say it is hydrozonium, we can say ozonium ion as the only positive ion. But when you have more than one positive ion, like where a metallic ion is added to it, so we have hydrogen ion and a metallic ion, we call it acidic salt. They will show some property that looks alike, like the acidic salt will turn blue litmus paper to red, but the main characteristics of an acid based on the chemical properties will not be seen in acidic salt. So we were able to distinguish the difference. So my specific objective lies on defining what a base is and grouping it into soluble and insoluble base, strong and weak bases, monoacidic, diacidic and triacidic bases, concentrated and diluted bases. And we're also going to look into how to prepare bases and what are the possible properties of bases, and we go ahead to look into two general uses of bases. So I have set up questions that I'm expecting you to be able to get at the end of this video. So you have to write them down as we did in our acid session. Write them down and expect to see the answers at the end of this video. Remember, I have actually discussed Arrhenius theory, I have discussed Bronsted-Lowry theory, I have discussed Lewis acid theory in the acid, where I said that Arrhenius says that is any substance that is capable of releasing hydrogen ion or increasing hydrogen ion concentration. That is what we mean by an acid. Whereas a base, according to what we have today, a base is a substance that is capable of reducing the hydrogen ion by introducing either an oxide or hydroxide or an amino group. I hope you get me on that. By Bronsted-Lowry is just any element or substance or radical or any substance that is capable of reducing or accepting the proton being released. So that is what we mean by a base. And according to Lewis acid theory, a base here is a substance that is capable of donating its lone paired electron to be shared by the two radicals or the substances. So we call them a base. So the one that is actually accepting it become an acid. But what do you actually mean by a base? Is a typical base. A typical base is an oxide, an amino group or a hydroxide that is able to neutralize an acid. This means the substance can reduce the number of hydrogen ions or hydronium ions or hydrozonium ions or ozonium ion present in a solution. That is what we will call it a base. Mind you, we still have basic salts that can do some of these things, like sodium tricarbonate. For salt, it can do that, but mind you, it will not be able to possess the two major chemical properties of a base, but it can be able to reduce the number of hydrogen ion or hydronium ion, but it is not included as an oxide, it is not included as an amino group, it is not included as a hydroxide. I hope you get me on that. So if it is an oxide, if it is an amino group, and if it is a hydroxide that is capable of reducing the hydrogen ion or neutralizing the hydrogen ion in an acid, then we call it a base. And I'm grouping these bases into soluble and insoluble bases, strong and weak bases, monoacidic, diacidic and triacidic bases, concentrated and diluted bases. Let's start with soluble bases. Another name for these soluble bases is alkali. These are metallic oxide and hydroxides of metals that dissolve in water. including the amino group that is able to dissolve in water. So we have all group 1 metallic oxide, so lithium oxide, potassium oxide, sodium oxide will dissolve in water. And hydroxide dissolve in water. That is, metallic hydroxide will dissolve in water, something like lithium hydroxide, sodium hydroxide, potassium hydroxide will dissolve in water. And they are given a special name, alkali metal. Yes, that is what we call them, those group 1 elements. So magnesium will slightly dissolve in water. That is magnesium oxide, or its hydroxide will hardly dissolve in water. Let's just put it like that. Calcium oxide and hydroxide sparingly dissolve in water. It dissolves in water more than the magnesium, but the rest of the group 2 elements, hydroxide and oxide, will dissolve in water, but not as the degree of that of group 1 and group 1 oxide and their metallic hydroxide. So group 1 are actually a soluble base. That is, their oxide and their metallic oxide are soluble bases, including all the possible amino group that are bases. Insoluble bases, these are metallic oxides and hydroxides of metals that are insoluble in water. So if you have listened to my discussion on soluble bases, anyone that I do not mention up there supposed to fall into an insoluble base. So we can have something like iron 2 oxide, iron 2 hydroxide, aluminum oxide, aluminum hydroxide. We can even go further to call something like magnesium oxide. We can go further to call copper oxide or copper hydroxide. They are all insoluble in water. So they are insoluble bases. They will still act like a base, but they will not be soluble in water. And that is actually one of the reasons why we do not define a base perfectly like Arrhenius. Arrhenius would have defined base as something that produces hydroxide ion or something that increases hydroxide ion in water. But that is only for soluble base. But because we want to define base, and not all bases dissolves in water, so we couldn't be able to define base using the hydroxide ion, something that produces hydroxide ion, because not all bases will dissolve in water. I hope you get me on that. Let's look into strong bases and weak bases. They are bases which the amount of the base that dissolve in water ionized completely. So all group 1 and group 2 oxides and hydroxide are strong bases. Magnesium hydroxide is a strong base, but not a strong alkali. What I mean by strong alkali, it is not a strong soluble base. This is because it has a low solubility in water, because it does not dissolve in water. But the amount of the hydroxide that is able to dissolve in water will ionize completely. If you look at this, you see that the little quantity of magnesium hydroxide or magnesium oxide that will dissolve in water will ionize completely. What about the one that do not ionize? So it makes magnesium to be falling into a strong base and a partial weak base, because not all is hydroxide will dissolve in water. It is being reacted with something like an acid. Some of the acids that are strong may overshadow them in hydrolysis. For instance, magnesium hydroxide reacting with hydrochloric acid will give you magnesium chloride. If you dissolve it in water, it will show a little bit red litmus paper. That is, if you add any litmus paper to it, it will turn it to red, because it is not all that magnesium are dissolving in water fighting against the chlorine inside the water. That is the magnesium oxide. I hope you get me on that. So it will not show its strength very well, but we know that magnesium hydroxide is a strong acid. What about what we mean by weak base? They are bases in which the amount of the base that dissolve in water ionizes partially. That is the opposite of strong base. We have the hydroxide of copper, we have that of zinc, we have that of lead. They are all weak bases. We even have ammonia. We have other oxide and hydroxide of beryllium, aluminium, zinc, tin, and lead, which are weak bases, but they also show a special character as a weak base, which they can react with both an acid and base to form salt. This property is what we know as amphoteric. So amphoteric substances are able to react with both acid and base to form salt. Classification of bases on the basis of number of hydroxide contained per molecule. We have monoacidic, we have all group 1 hydroxides like potassium hydroxide, sodium hydroxide, lithium hydroxide, and they are also soluble in water and also strong base. I hope you get me. So we have diacidic, all group 2 hydroxides and also zinc and copper are also example of diacidic hydroxide. So they have 2 hydroxide as you can see on the screen. We have triacidic like all group 3 hydroxide. Example is aluminum hydroxide, although this aluminum hydroxide shows amphoteric nature. We have classification of base based on amount of base solutes, that is based on, we are looking at concentrated and diluted base. For concentrated base, this is a solution of base which the amount of the base is higher than that of the water. When it is a strong alkali, it is corrosive. So strong base that are soluble in water will be very, very corrosive. They will cause irritation on the skin. For dilute base, this solution of base has more water than the solute base. I know you can compare your idea with that of acid as we discussed it before, and you see that they are very, very close to one another. So I want you to look at these questions, write them down before we continue. Preparation of bases. There are ways we can prepare base. We have one, burning of metals in the presence of oxygen to form metallic oxide. This is a simple equation that can demonstrate that. We also have reaction of metals with water to form oxides or hydroxide. We have something like sodium reacting with water to give us sodium hydroxide and hydrogen being eliminated. We also have dissolution of soluble metallic oxide to form hydroxide. That is how we can also form something like base, as you can see on the screen, because this one is actually formation of hydroxide. I hope you get me on that. Okay, so we also have physical properties of bases. Physical properties of bases, they test bitter. For acid, they test sour. Mind you, no one asks you to go and test this in the laboratory, except your teacher asks you to do so. 2, they are soapy feel to touch. You can just try this one at home. When you touch your soap, you touch your toothpaste, they look alike. That is why 2 of them produces this foam when they are being put inside water or being turned hardly or stirred hardly, so you feel that soapy feel. So the concentrated strong bases are corrosive just like acid, but mind you, whether it is concentrated, whether it is strong, be careful with base and acids. They turn litmus blue. That means that if you bring a red litmus paper, it's going to turn to blue. If you bring a blue litmus paper, it will turn to blue. But for acid, if you bring a blue litmus paper, it will turn to red. If you bring a red litmus paper, it will remain red. The reason why I even use a blue background on my video here is because of I'm discussing a base, which I believe a base will turn litmus paper to blue. That is why you see me using the blue background here. 5, their pH is always above 7, whereas for acid, the pH of acid is always below 7. Chemical properties of a typical base. Reaction with an acid to form water and salt in what we call a neutralization reaction. These are examples of that, where tetrasulfuric acid reacted with sodium hydroxide to give us water and sodium tetraoxosulfate 6. Although we have this reaction in 2 places where it will give us an acidic salt. The first one is not an acidic salt, is a common salt and a neutral salt, but the second one is an acidic salt. The presence of hydrogen there make it an acidic salt, because the presence of hydrogen is always calling for an acid. But when it is only hydrogen ion, we say it is pure, a typical acid. But if it has a hydrogen ion at the same time a metallic ion, we call it an acidic salt. Okay, they liberate ammonia from ammonium salts. In chemistry practicals, WAEC NECO, sometimes they can say that hydroxide is being added, something like sodium hydroxide is being added to a salt and heated. They will ask you to heat it. When you heat it, the smell is going to give you ammonia smell, choking smell. So you confirm that there is ammonium ion there. Okay, for the uses of bases, we have making of cleaning agents like soaps, detergents, making of toothpaste. Thank you very much for clicking on this video. Thank you very much for watching this video to this extent.